Combustion chamber. The space enclosed in the upper part of the cylinder by the cylinder head and the piston top during the combustion process is called the combustion chamber. The combustion of fuel and the consecutive release the thermal energy results in the building of pressure in the part of the cylinder. Inlet manifold. Inlet manifold. Inlet manifold is here. It is this portion is called inlet manifold. Inlet manifold, the pipe which connects the intake system to the inlet valve of the engine, the through which air or air fuel mixtures is drawn into the cylinder is called the inlet manifold. Exhaust manifold. Exhaust manifold is here. Exhaust manifold is here, this portion. Exhaust manifold. From this portion, exhaust product is releasing from this. Exhaust manifold, the pipe which connects the exhaust system to the exhaust valve of the engine and through which the products of the combustion escape into the atmosphere is called the exhaust manifold. Now next is inlet and exhaust valves. Inlet and exhaust valve. Inlet valve and inlet manifold are not as same things. It is different part. You can see this is the inlet manifold. Inlet valve is called from this. This is the inlet valve and inlet manifold is called this portion. This part is called inlet manifold and this valve, this portion is called inlet valve. On the other side you can see exhaust valve. This is the exhaust valve and exhaust manifold. This portion is called exhaust manifold. So inlet and exhaust valves. Valves are commonly mushroom shaped, poppet type. They are provided either on the cylinder head or on the side of the cylinder for regulating the charge coming into the cylinder, inlet valve, and for discharging the products of the combustion, exhaust valve, from the cylinder. Spark plug. Spark plug is placed here. Spark plug is here. It is the spark plug. Spark plug. It is a component to initiate the combustion process in spark ignition engines. Spark ignition means SI engines and is usually located on the cylinder head. A spark plug is located on the cylinder head. You can see this is the spark plug which is placed on the cylinder head. This is the cylinder. This is the cylinder It is located here. Spark plug. Next, spark plug. It is a component to initiate the combustion process in spark ignition SI engines and is usually located on the cylinder head. Connecting rod. It is, you can see connecting rod. Where is it? It is connecting rod is here. This is the connecting rod. It is connect the piston and crank by the help of gauge pin and crank pin. Connecting rod, sorry, seems clearly. Connecting rod, it is interconnect the piston and the crankshaft and transmit the gas forces from the piston to the crankshaft. The two ends of the connecting rod are called as small end and the big end. Small end is connected to the piston by gauge pin and the big end is connected to the crankshaft by crank pin. Next is crankshaft. What is crankshaft? You can see this is called crankshaft. Here you can see this is the crankshaft. This is the crankshaft. Crankshaft maybe connect 2 or 4 uh, more than one crank can be connected by the crankshaft. This is crankshaft. It is connect the reciprocating motion of the piston into useful rotary motion of the output shaft. It is not visible. Now it is visible clearly. Crankshaft, it converts the reciprocating motion of the piston into useful rotary motion of the output shaft. In the crankshaft of the single cylinder engine, there are a pair of crank arms and balance weights. The balance weights are provided for static and dynamic balancing of the rotary system. The crankshaft is enclosed in a crankcase. Next, what is piston ring? I am showing the piston rings here. Piston ring. Here you can see piston ring. Here are nodes. So piston ring. Piston ring. Maybe here, but not so. Here. Piston ring and not draw in the figures, but we have to understand by the theory. Piston rings are fitted into the slot around the piston, uh, provide a tight seal between the piston and the cylinder wall, thus preventing leakage of combustion gases. Figure 1.3. It is figure 1.3. It is 1.3. Here you can see in this figure piston ring. This is called piston ring. These three line three lines is called piston ring. You can see also here three, 1 2 3 is these three rings are called piston rings. Next, next is Gaussian pin. Gaussian pin, it's form the link between the small end of the connecting rod and the piston. I'm so I'm showing the Gaussian pin. Gaussian pin, you can see this is called Gaussian pin. This pin is called Gaussian pin. It is connected. It is connecting piston and connecting rod. Next is camshaft. 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 The camshaft and its associated parts control the opening and closing of the two valves. The associated parts are push rod, rocker, arms, valve springs, and tappets. This shaft also provides the drive to the ignition system. The camshaft is driven by the crankshaft through timing gears. I am showing the crankshaft. This is what crankshaft. Crankshaft. Here I am focusing the crankshaft. This is called crankshaft. It is not a small thing. It may be big size in length. It connected more than one crank. The crankshaft and its associated parts control the opening and closing of the two valves. The associated parts are push rods, rocker, arms, valve springs, and tappets. This shaft also provides the drive to the ignition system. The camshaft is driven by the crankshaft through timing gears. Next is cam. Cams. Next is cam. These are made as integrated parts of the crankshaft and are designed in such a way to open the valves at the correct timing and to keep them open for the necessary duration. Cams. Next is flywheel. Flywheel is not visible properly. Now it is visible. Flywheel. The net torque to the crankshaft during one complete cycle of operation of the engine fluctuate, fluctuates, causing a change in the angular velocity of the shaft. In order to achieve a uniform torque and inertia, mass in form of a wheel is attached to the output shaft, and this wheel is called the flywheel. Next is next is cylinder bore. cylinder bore, it is denoted by small d. The uh, nominal inner diameter of the working cylinder bore and is designated by the letter small d and is usually expressed in millimeter diameter, usually expressed in millimeter diameter, is expressed in millimeter. Piston area, it is denoted by capital A. The area of a circle of diameter equal to the cylinder bore is called the piston area. The area of a circle of diameter equal to the cylinder bore is called the piston area and is designated by the letter A and is usually expressed in square centimeter square. Stock. It is denoted by capital L. The nominal distance through which a working piston moves between two successive reversals of its direction of motion is called the stock and is designated by the letter capital L and is expressed usually in millimeter stock to bore ratio. Stock to bore ratio, capital L upon small d. Small d is cylinder bore, capital L is stock. Ratio is an important parameter in classifying the size of the engine. Size of the engine. To classify the size of engine, ratio L upon D by L upon D. Can we classify the size of engine by L upon D? If D is uh, uh, if D is less than L, it is called under square engine. Under square engine. If D is equal to capital L means stock, it is called square engine. Under square engine, its means d is less than d is less than l, and d is equal to l. It is called square engine. If d is greater sorry d is greater than l, it is called over square engine. An over square engine can operate at higher speed because of larger bore and shorter stroke. जब d छोटा हो जाए l से, तब अंडर स्क्वायर इंजन बनेगी. जब d और l मीन्स सिलेंडर बोर और स्टॉक समान हो जाते हैं, इन केस में इस केस में स्क्वायर इंजन बनती है. और जब स्मॉल डी छोटी हो जाती है कैपिटल एल से, मीन्स सिलेंडर बोर छोटा हो जाता है जब स्टॉक से, तो ओवर स्क्वायर इंजन बनती है. An over square engine can operate at higher speeds because of larger bore and shorter stroke. Dead center. Dead center, the position of the working piston and the moving parts which are mechanically connected to it. At the moment when the direction of the piston motion is reverse at either end of the stroke is called the dead center. There are two dead centers in the engine as indicated in figure 1.3. This is the piston arrangement. This portion is called, this space is called clearance volume. From this line to this line, lower line to upper line. This area is called clearance volume. This line is called TDC, top dead center, and these three lines are called piston ring. This pin is called Gaussian pin, and this is the piston, and piston BDC means bottom dead centers. Piston move TDC to BDC. This is connecting rod. This is the piston cylinder case. Bore means both diameter D. From here to here, this is express the diameter of the cylinder. From this TDC to BDC is called a stock length. It is represented by capital L. This small pin is called
आप ऐसे मैं
small
बताओ
end,
देखिए क्या क्या बोलूँ फिर से।
small end.
उसमें फोटो लिखा हुआ है, यहाँ का फोटो। हाँ।
Piston at button dead center.
तो इसमें नाम क्या लिखा हुआ है?
Small
यहाँ
end.
का नहीं, बुश के नाम लिखा हुआ है।
Big end, small
नहीं
end.
वाटर नहीं, वाटर नहीं,
This is
कोई
the
और।
small end.
वाटर नहीं, कोई और।
And
सिर्फ
this is the big
कोई भी
end.
एथलेटिक का नंबर। हाँ काय कर रहा है, तुम काय कर रही है आप बताओ।
Big end.
काय कर, तुम काय कर रही है?
Displacement or swept volume, Vs. The nominal volume swept by the working piston when the traveling one end from one dead center to the another is called the displacement volume. It is expressed in terms of cubic time a centimeter. It is expressed in terms of cubic centimeters, means cc, 1 cc, 2 cc, 3 cc, and given by bs is equal to area into l, stock length. L is stock length. Area is area area volume, no, area cylinder volume from dead center to bottom dead center, top dead center to bottom dead center. Area is equal to, we can say, pi by 4 d square into l. L is stock length. Area d is diameter of bore, diameter of door, bore, piston diameter, piston diameter, no, it is, you can see, this is the bore, this is also called diameter, from here to here. This is piston, this is piston, this to this point, this point to this point, length is called diameter. Diameter means piston diameter. cc, bs is equal to area into l. Here this is formula, pi by 4, pi upon 4 into d square into l. Next is cubic capacity or engine capacity. The displacement volume of a cylinder multiplied by number of cylinders in an engine will give the cubic capacity or the engine capacity. For example, if there are k cylinders in an engine, then cubic capacity will be bs into k, bs into k. K is number of cylinder. K means number of cylinder, and this is displacement, yeah, swept volume. Next, clearance volume VC. The nominal volume of the combustion chamber above the piston when it is at the top dead center is the clearance volume. It is designated as Cc and expressed in cubic centimeter Cc. Clearance volume. Clearance volume. Volume. It is showing here. This space is called clearance volume. From this line to this line, clearance volume. The nominal volume of the combustion chamber above the piston, when it is at the top dead center. जब ये टॉप डेड सेंटर पर होते हैं, इज द क्लियरेंस वॉल्यूम, उसमें होती है पिस्टन से ऊपर सिलेंडर से लाइन नीचे लाइन से सिलेंडर के नीचे लाइन से पिस्टन के ऊपर लाइन तक क्लियरेंस बराबर होती है जब पिस्टन टॉप में हो. It is designated as with and expressed in cubic centimeter cc. Compression ratio is denoted by small r. It is the ratio of the total cylinder volume. Total cylinder volume when the piston is at the bottom dead center. Compression ratio. Total cylinder volume when the piston is at the bottom dead center. TBT to the clearance volume. Yes. How to find it? It is denoted by the small r. Small r is equal to Bt upon Bc. Vc plus Vs upon Vc equal to 1 plus Vs upon Vc. This is very important formula. R is compression ratio. Compression ratio how to find from this equation. By the help of this equation we can find the compression ratio. The working principle of engines. If an engine is to work successfully, then it has to follow a cycle of operations in a sequential manner. The sequence is quite rigid. Control be changed. Cannot be changed. The sequence is quite rigid and cannot be changed. In the following section, the working principle of both SI and CI engines is described. When though both engines have much in common, there are certain fundamental differences. The credit of inventing the spark ignition engine goes to Nicholas A. Otto. The credit of inventing the spark ignition engine goes to Nicholas A. Otto, 1876, whereas compression ignition engine was invented by Rudolf Diesel. 1892. Otto and Diesel. Otto 1876, Diesel is 1892. Therefore, they are often referred to as Otto engine and Diesel engine. Four-stroke spark ignition engine. Four-stroke spark ignition engine. In a four-stroke engine, the cycle of operation is completed in four strokes of the piston or two revolutions of the crankshaft. During the four-stroke, there are 5 events to be completed, viz. Suction, compression, combustion and expansion. Suction, compression, combustion, expansion and exhaust. Suction, compression, combustion, expansion and exhaust. Each stroke consists of 180 degree of crankshaft rotation, and hence a four-stroke cycle is completed through 720 degree four-stroke cycle is completed through 720 degree. Each stroke consists of 180 degree and four-stroke cycle is completed through 720 degrees of crank rotation. The cycle of operation for an ideal four-stroke spark ignition engine consists of the following four strokes: suction or intake stroke, second is compression stroke, third is expansion or power stroke, and fourth is exhaust stroke. The details of various processes of a four-stroke spark ignition engine with overhead valves are shown in figure 1.4 AD. When the engine completes all the five events under ideal cycle mode, the PV diagram will be as shown in figure 1.5. This is the intake figure, this is the compression, this is the exhaust, and this is expansion and exhaust. This intake, here intake, and this is the compression. Piston is going to upward, and then here piston is going to downward, and in this case expansion, piston is going again downward, and exhaust, this is piston is in the top dead center. Yeah, maximum upward distance, in maximum upward distance. Next, working principle of four-stroke SI engine. We see next, we will see next suction or intake stroke. Suction and intake stroke. Suction stroke 0 to 1, figure 1.5. Where is it? Is it here in PB diagram? 0 to 1 is showing the suction or intake stroke. 0 to 1. 0 to 1 is suction intake. 1 to 2, 1 to 2 compression, and 2 to 3, 2 to 3 suction, compression,
हेलो
compression,
क्या
and
हुआ?
then power stroke.
अबे खान कह रहे तो ऐसे बात
Compress
बात करते हैं पहाड़ का फोन आ रहा है पास
and
में बात करते
3
हैं
to 4, 3 to 4 expansion
अरे पहाड़
and
का
4
बात कर
to
रहे हैं अभी तो ऐसे में
1 exhaust, and 5 to 0, 5 to 0, 5 to 0. Not confirm. I have to see one by one. This is point one number is suction and intake stock. Suction stock 0 to 1 starts when the piston is at the top dead center and about to move downward. The inlet valve is open at this time and the exhaust valve is closed. Figure 1.4a, 1.4a. You can see this is this figure is ये वाली है. Due to the suction created by the motion of the piston towards the bottom dead center, the charge consisting of fuel air mixture is drawn into the cylinder. When the piston reaches the bottom dead center, the suction stroke ends and the inlet valve closes. Okay. 0 to 1 is suction. Compression stroke. Compression stroke. The charge taken into the cylinder during the suction stroke is compressed by the return stroke of the piston. 1 to 2. From 1 to 2. You can see in figure 1.5. During this stroke, both inlet and exhaust valves are in closed position. You can see it figure 1.4b. The mixer which fill the entire cylinder volume is now compressed into the clearance valve. At the end of the compression stroke, the mixer is ignited with the help of a spark plug located on the cylinder head. In ideal engines, it is assumed that burning takes place instantaneously when the piston is at the top dead center, and hence the burning process can be approximated as addition at constant volume. During the burning process, the chemical energy of the fuel is converted into heat energy, producing a temperature rise up to 2000 degrees Celsius. Process 2 to 3. Figure 1.5 means PV diagram. Figure 1.5, the pressure at the end of the combustion process is considerably increased due to the heat released from the fuel. During the burning process, the chemical energy of the fuel is converted into heat energy, producing a temperature rise of about 2000 degrees Celsius in constant volume. This is showing constant volume, and in this position, burning process, chemical energy of fuel is converted into heat energy. Chemical energy converted into heat energy. 2 to 3 in this position in constant volume. 3 to 4 is expansion. Volume is increasing. expansion or power stroke. The high pressure of the burn gases forces the piston towards the BDC bottom dead center. Stroke 3 to 4. 3 to 4 is expansion or power stroke. Figure 1.5 means PV diagram. Both the valves are in closed position. Figure 1.4c of the four strokes only during this stroke power is produced. Both pressure and temperature decreases during expansion. During expansion process, pressure and temperature is in decreasing. यह decreases. प्रेशर और टेम्परेचर घटती है एक्सपेंशन प्रोसेस के दौरान प्रेशर और टेम्परेचर घटती है. स्वेप्ट वॉल्यूम, क्लियरेंस वॉल्यूम, दिस इज द total volume. B is total volume. P is, yeah, this is the volume. This is P is pressure. 0 to 1 suction and 1 to 2 process. Stroke 1 to 2 is called compression, and 2 to 3 it is converting chemical energy into thermal energy, means heat energy in constant volume. And 3 to 4 is expansion, which is power stroke. Next is exhaust stroke. At the end of the expansion stroke, an exhaust valve opens and the inlet valve remains closed. The pressure falls to atmospheric valve. A part of the burn gases escapes. The piston starts moving from bottom dead center to top dead center. Stop 5 to 0. 5 to 0. Figure 1.5, the swept the burn gases out from the cylinder almost at atmospheric pressure. The exhaust valve closes when the piston
हाँ, हेलो, क्या हुआ बताएं तब.